Chapter 1: A Rifle Ahead of Its Time. On a frozen hill in Korea and a hedgerow in Normandy, the same metallic ping echoed across battlefields separated by thousands of miles and years of war. It was the sound of an empty clip ejecting from an M1 Garand rifle, a distinct signature that marked the end of 8 rounds fired faster than any bolt-action weapon could match. That ping became the auditory symbol of American infantry power in the middle decades of the 20th century, a mechanical noise that carried with it the weight of industrial might and tactical superiority. The story of the M1 Garand begins not on a battlefield, but in the quiet workrooms of Springfield Armory in Massachusetts, during the years between the 2 world wars. John Cantius Garand, a Canadian-born engineer who had immigrated to the United States as a young man, possessed an obsessive dedication to firearms design that would ultimately reshape modern warfare. Born in 1888 in Saint-Rémy, Quebec, Garand had begun his career designing firearms for private manufacturers before joining Springfield Armory in 1919. The US Army, having observed the brutal lessons of the First World War, understood that future conflicts would demand higher volumes of fire from individual soldiers. The bolt-action Springfield Model 1903, while accurate and reliable, required a soldier to manually work the bolt between each shot, fundamentally limiting the rate of fire to what a trained rifleman could achieve through repetitive mechanical action. The quest for a semi-automatic service rifle had begun in earnest during the 1920s. Military theorists recognized that semi-automatic operation, using the energy from a fired cartridge to automatically load the next round, could double or triple a soldier's effective rate of fire without sacrificing accuracy. Multiple designers submitted prototypes, each attempting to solve the complex engineering challenges inherent in creating a reliable, durable, and cost-effective semi-automatic mechanism capable of functioning in the mud, sand, rain, and extreme temperatures that characterize combat environments. Garand's design evolved through years of testing and refinement. Early prototypes used a primer-actuated system, but by the early 1930s, Garand had shifted to a gas-operated mechanism that would prove more reliable. His design used expanding gas from the fired cartridge, channeled through a port in the barrel, to drive an operating rod backward. This rearward motion ejected the spent cartridge case and compressed a spring. As the spring expanded again, it drove the bolt forward, stripping a fresh cartridge from the magazine and chambering it, ready for the next shot. The entire cycle occurred in a fraction of a second, allowing a soldier to fire as rapidly as he could pull the trigger. In January 1936, after years of competitive trials against rival designs, the United States Army officially adopted Garand's rifle as the US rifle, caliber .30 M1. This decision represented a revolutionary commitment that no other major military power would match before the Second World War. The rifle chambered the powerful .30-06 Springfield cartridge, the same round used in the bolt-action Model 1903, ensuring compatibility with existing ammunition stocks. Its most distinctive feature was the 8-round en-bloc clip, a metal container that held cartridges in a single unit. The entire clip was inserted into the rifle from the top, pushing down until it locked into place with a metallic click. After the 8th round was fired, the empty clip would be automatically ejected upward with that characteristic ping, falling away as the bolt locked back, signaling the rifle was empty and ready for a fresh clip. Early skepticism within military circles was substantial. Conservative officers questioned whether average soldiers could maintain the more complex mechanism. Others worried about ammunition consumption, fearing that troops armed with semi-automatic weapons would waste bullets in undisciplined fire. The rifle's weight, at approximately 9.5 pounds unloaded, was greater than many bolt-action contemporaries. Questions arose about reliability, about whether the gas system would foul after sustained firing, and whether the rifle could withstand the abuse of field conditions. Yet the M1 Garand possessed qualities that transcended these concerns. Its construction combined traditional walnut stocks with machined steel components of exceptional precision. The gas system, while more complex than a simple bolt-action mechanism, proved remarkably robust. The rifle's accuracy matched that of bolt-action weapons, capable of striking man-sized targets at ranges exceeding 400 yards. Perhaps most importantly, the psychological advantage of rapid fire without manual bolt cycling gave American soldiers a confidence that would prove decisive in combat. To understand the revolutionary nature of the M1 Garand, one must consider what soldiers of other nations carried into battle. German infantry, often portrayed as mechanized and modern, primarily relied on the Karabiner 98K, a bolt-action rifle descended from designs dating to the 1890s. The Kar 98K was an excellent weapon, accurate and reliable, but each shot required the soldier to lift his firing hand, grasp the bolt handle, pull it rearward, push it forward, and rotate it down to lock, then reacquire his sight picture before firing again. A well-trained German soldier could fire perhaps 15 aimed rounds per minute under ideal conditions. Japanese forces carried the Type 38 and later Type 99 Arisaka rifles, also bolt-action designs of high quality but limited in rate of fire by their manual operation. British Commonwealth troops used the Lee Enfield, arguably the finest bolt-action rifle of the war, with a smooth action and 10-round magazine that allowed rapid fire by the standards of manual weapons. Yet even the Lee Enfield, in the hands of an expert, could not match the sustained fire rate of a semi-automatic weapon operated by a soldier of average skill. The Soviet Union had adopted the Tokarev SVT-40 semi-automatic rifle, but production limitations, maintenance difficulties in field conditions, and the prioritization of submachine gun production meant that most Soviet infantry still carried Mosin Nagant bolt-action rifles throughout the war. Only the United States had committed to equipping its entire infantry force with semi-automatic rifles as standard issue. This commitment framed the central question that would be answered on battlefields from North Africa to the Philippines. How would a force of soldiers, each armed with a weapon capable of firing 8 rounds as rapidly as they could pull the trigger, perform against enemies who had to manually cycle a bolt between shots? The answer would reshape tactical doctrine, alter the mathematics of small unit combat, and create a legend that would endure long after the last shot was fired. The M1 Garand represented more than technical innovation. It embodied a fundamental shift in how the United States approached warfare, reflecting an industrial and economic capacity that could afford to arm every soldier with what other nations reserved for specialized troops. In 1936, as the rifle entered service and the world moved inexorably toward global conflict, few could have predicted that this weapon would become what General George S. Patton would later call the greatest battle implement ever devised. But in the years to come, on every continent where American soldiers fought, the sound of the Garand would announce a new era in infantry combat. Chapter 2. Forged by Industry. The adoption of the M1 Garand in 1936 presented the United States with a manufacturing challenge of unprecedented scale. Springfield Armory, the federal facility that had produced military firearms since 1794, now faced the task of transforming a prototype into a production weapon that could be manufactured by the hundreds of thousands, then millions, without sacrificing the precision that made the rifle function reliably. Springfield Armory, located along the banks of the Connecticut River in Massachusetts, had been the cradle of American military firearms development for over a century. Its skilled workforce of machinists, toolmakers, and inspectors possessed knowledge accumulated across generations of weapons production. Yet the M1 Garand demanded tolerances and production techniques that pushed even this experienced facility to its limits. Each rifle contained approximately 50 separate components, many requiring machining operations measured in thousandths of an inch. The receiver, the steel frame that housed the firing mechanism, had to be forged, heat-treated and precisely machined to accept the bolt, trigger assembly and operating rod with exacting tolerances. Initial production began slowly. In 1937, Springfield Armory produced just over 2,000 M1 rifles. Small modifications emerged from early field testing, minor adjustments to springs, extractors, and gas cylinder assemblies. By 1938, production had increased to approximately 8,000 rifles. Engineers refined manufacturing procedures, developing specialized fixtures and gauges that allowed workers to produce components within specification more quickly and reliably. The rifle's gas system required particular attention. The gas cylinder, which contained the operating rod and trapped the gas that drove the action, had to be precisely aligned with the barrel's gas port. Any misalignment could result in malfunctions. The outbreak of war in Europe in September 1939 accelerated American rearmament efforts. President Franklin D. Roosevelt recognized that American industry would need to expand dramatically to meet potential wartime demands. The M1 Garand, still being produced only at Springfield Armory, would need additional manufacturing capacity. In 1939, The Winchester Repeating Arms Company received the first contract to produce M1 rifles at its facility in New Haven, Connecticut. Winchester faced the challenge of translating Springfield's manufacturing knowledge to a private factory. Engineers travelled between facilities, carrying blueprints, specifications, and practical knowledge gained from 2 years of production experience. Winchester's first M1 rifles emerged from the production lines in 1940, initially at slower rates as workers mastered the complex assembly procedures. By 1941, both facilities had substantially increased output, though production numbers remained modest by the standards that would soon be required. The Japanese attack on Pearl Harbor on December 7, 1941, transformed the American economy into a fully mobilized wartime industrial system. The demand for M1 Garand rifles suddenly became almost unlimited. The US Army planned to field millions of soldiers, each requiring a rifle. Marines, initially resistant to adopting the M1, began requesting the weapon after combat experience in the Pacific demonstrated its superiority over the Springfield Model 1903 bolt-action rifles they had initially carried. Springfield Armory operated around the clock, 3 shifts of workers cycling through every 24 hours. The facility expanded physically, new buildings rising to house additional machinery. Winchester similarly expanded its production lines, yet even these 2 facilities could not meet demand. In 1943, 2 additional contractors joined production: International Harvester, better known for agricultural equipment, and Harrington and Richardson, a firearms manufacturer in Massachusetts. The challenge of maintaining quality while increasing quantity required systematic approaches to manufacturing. Each rifle component bore inspection stamps, small markings indicating that a quality control inspector had verified dimensions and finish. Final assembled rifles underwent proof testing, firing special high-pressure cartridges that exceeded normal operating pressures to ensure the receiver and barrel could withstand the stress. Rifles that passed proof testing received additional markings stamped into the receiver, recording the month and year of manufacture, the facility that produced it, and its serial number. Serial numbers became a detailed record of wartime production. Springfield Armory rifles bore serial numbers beginning with simple numerals, eventually exceeding 3,600,000 by war's end. Winchester rifles had serial numbers beginning with W prefix followed by numerals. International Harvester used various suffix and prefix schemes. Harrington and Richardson produced rifles in smaller quantities during the final years of the war. This system allowed the military to track production, identify manufacturing trends, and address quality issues when they emerged. The workforce that built these rifles reflected wartime demographics. As men joined military service, women increasingly filled factory positions. Training programs taught new workers to operate lathes, milling machines, and drill presses. Rosie the Riveter had her counterparts in the precision machining shops, where Garand receivers were shaped from steel forgings. The work demanded concentration and skill. A receiver machined with even slightly out-of-tolerance dimensions might cause the rifle to malfunction, potentially costing a soldier his life on a distant battlefield. Production cost per rifle varied across the war years, but averaged approximately $85 per unit, equivalent to nearly $1,500 in current value when adjusted for inflation. This represented a substantial investment compared to bolt-action rifles, which cost approximately $50 to produce. Yet American industrial capacity and economic resources made this additional expense manageable. The United States produced over 5,400,000 M1 Garand rifles between 1937 and 1945, a manufacturing achievement that no other nation approached for semi-automatic rifles during the war. The rifle's adoption required corresponding changes in ammunition production and logistics. The .30-06 Springfield cartridge, adopted in 1906, had been in military service for decades, but the increased rate of fire from semi-automatic weapons meant each soldier would consume ammunition far more rapidly than with bolt-action rifles. Ammunition production expanded massively, with contracts distributed to numerous manufacturers. The 8-round on-block clip, a seemingly simple pressed steel component, required its own production infrastructure. Millions of clips were manufactured, distributed through supply channels, and shipped to every theatre where American forces operated. Training evolved to incorporate the new weapon. Soldiers arriving at basic training facilities learned to field strip the M1 Garand, breaking it down into its major components for cleaning and maintenance. They practiced loading the 8-round clips, learning to press down firmly until the clip locked into place, avoiding the painful M1 thumb that occurred when the bolt slammed forward on an unwary thumb during loading. They fired thousands of rounds on rifle ranges, learning the weapon's recoil characteristics, trigger pull, and sight picture. Doctrine shifted to leverage the rifle's capabilities. Squad tactics now assumed that every rifleman could deliver sustained rapid fire. Suppressive fire, previously the domain of machine gun crews, could now be provided by individual soldiers with M1 rifles. Fire and maneuver tactics became more fluid when every soldier possessed rapid-fire capability. The BAR, or Browning automatic rifle, remained in service as the squad automatic weapon, but the gap between its full automatic fire and the rifleman's capability had narrowed substantially. Maintenance in field conditions presented ongoing challenges. The M1 Garand, while remarkably reliable, required regular cleaning and lubrication. Soldiers learned to disassemble the gas cylinder, clean carbon fouling from the gas piston, and apply lubricant to the operating rod. In tropical environments, moisture and humidity threatened to cause rust. In desert conditions, sand and dust infiltrated mechanisms. In cold weather, excessive lubricant could freeze, causing malfunctions. Soldiers adapted, learning which lubricants worked best in their environment, carrying cleaning patches and bore brushes, developing informal maintenance procedures passed from veteran to replacement. The American industrial system had accomplished something unprecedented: the mass production of a complex semi-automatic rifle that functioned reliably under the worst conditions imaginable. From the precision machining shops of Springfield and Winchester to the foxholes of Normandy and Okinawa, the M1 Garand represented American manufacturing capability translated directly into combat power. The rifle was not merely a weapon, it was industrial capacity made tangible, a product of factories, workers, engineers, and an economy that could afford to give every soldier an advantage that enemies could not match. Chapter 3: The Garand in Battle. The first major combat test of the M1 Garand came in the jungles and volcanic sands of the Pacific Theatre. On August 7, 1942, the 1st Marine Division landed on Guadalcanal in the Solomon Islands, beginning a 6-month campaign that would establish the rifle's reputation under the harshest combat conditions. Marines, many still carrying Springfield Model 1903 bolt-action rifles, quickly learned to appreciate the M1's capabilities. Japanese forces, armed with Arisaka bolt-action rifles and light machine guns, initially held tactical advantages born from jungle fighting experience and prepared defensive positions. But when American forces equipped with M1 Garands engaged in close-quarters combat in dense vegetation, the advantage shifted. The jungle environment reduced engagement ranges dramatically. Visibility often extended only 20 or 30 yards through thick undergrowth. In these conditions, the ability to fire rapidly without working a bolt became decisive. A Marine encountering a Japanese soldier at close range could fire multiple aimed shots in the time it took an opponent to cycle his bolt for a second round. After-action reports from Guadalcanal consistently mentioned the M1's superiority in jungle combat. The psychological impact proved significant as well. Japanese troops, accustomed to their own discipline and willingness to close with the enemy, found themselves facing opponents who could deliver devastating volumes of accurate fire in seconds. The rifle's reliability in tropical conditions initially raised concerns. High humidity, constant moisture, and the corrosive effects of salt air threatened metal surfaces. Soldiers learned to keep actions clean and properly lubricated, though excessive oil could attract dirt and debris. The M1's gas system, despite fears about fouling, proved remarkably tolerant of less than ideal maintenance. Rifles that had fired hundreds of rounds without cleaning continued to function, though accuracy might degrade as carbon buildup accumulated in the barrel. The weapon's reputation for reliability grew with each campaign. North Africa provided a contrasting environment. American forces landing in Morocco and Algeria in November 1942 as part of Operation Torch carried M1 Garands into their first combat against German forces. The open desert terrain allowed longer engagement ranges, where the rifle's accuracy at 300 to 400 yards proved valuable. Sand presented maintenance challenges different from jungle moisture. Fine dust infiltrated actions requiring frequent cleaning. Soldiers learned to cover muzzles and actions when not in immediate combat, protecting mechanisms from abrasive particles. The Battle of Kasserine Pass in February 1943, an early American defeat against German armoured forces, demonstrated both the rifle's capabilities and the limitations of equipment without proper tactical employment. American infantry, many fighting their first battle, initially struggled against experienced German units. Yet even in defeat, reports from German forces noted the rapid rate of fire from American riflemen. As American troops gained combat experience through the North African campaign, the tactical advantages of the M1 became more apparent. Infantry units learned to coordinate fire, with groups of riflemen delivering sustained volleys that suppressed enemy positions while other elements manoeuvred. Sicily and Italy brought the M1 Garand into mountain warfare. The rugged terrain of Italy's Apennine Mountains created challenging conditions, where combat often occurred at close ranges on steep hillsides and in narrow valleys. The rifle's weight, approximately 9.5 pounds, became more noticeable during extended marches with full combat loads, yet that weight also contributed to stability during firing and helped manage recoil from the powerful .30-06 cartridge. Soldiers ascending steep trails to attack German defensive positions appreciated the firepower they could bring to bear once contact was made. The characteristic sound of the rifle became intimately familiar to anyone who served in combat. The initial firing produced a sharp crack, the .30-06 cartridge generating substantial muzzle blast. Recoil pushed solidly into the shoulder, manageable but substantial enough that soldiers learned to hold the weapon firmly to avoid bruising. After 8 rounds, the distinctive metallic ping of the ejecting en-bloc clip became a signal that every soldier recognized instantly. For the rifleman, it meant inserting a fresh clip and chambering another round. For nearby soldiers, it meant one of their squad mates was reloading, and for the enemy, according to later accounts, it sometimes signaled that an American rifleman was temporarily vulnerable. The debate about whether the clip's ejection ping compromised soldiers tactically has generated discussion for decades. The reality appears more nuanced than popular mythology suggests. In the chaos of combat, with multiple rifles firing, explosions, and general noise, identifying a single clip ejecting from a specific position proved difficult. German and Japanese soldiers interviewed after the war occasionally mentioned hearing the sound, but few described it as a reliable tactical indicator. Some American veterans reported that the ping was simply part of the ambient noise of battle, rarely noticed except by the soldier whose rifle had just emptied. Nevertheless, the legend persisted, perhaps because the sound was so distinctive and memorable that it assumed greater significance in retrospect than it possessed in the moment. The Normandy invasion on June 6, 1944, represented the largest amphibious assault in history and provided another test of the M1 Garand under extreme conditions. Soldiers wading ashore through surf, exposed to German machine gun and artillery fire, carried rifles that had been submerged in salt water. The M1's reputation for reliability was tested immediately. Most rifles functioned despite immersion, though some required field maintenance to clear water from actions and gas cylinders. As infantry pushed inland through the hedgerow country of Normandy, combat devolved into close quarters, fighting in confined spaces between ancient earthen embankments topped with thick vegetation. The hedgerows created conditions similar to jungle warfare, with limited visibility and sudden encounters at short range. The M1's rapid-fire capability again proved decisive. German forces, primarily equipped with Kar-98K bolt-action rifles and supplemented by MG-42 machine guns, found themselves facing American infantry that could deliver squad-level fire volumes unprecedented for rifle-armed troops. A single American squad of 12 men, each with an M1 Garand, could fire 96 rounds without reloading. In practice, with staggered reloading, a squad could maintain continuous fire at a pace that rivaled light machine gun volumes. The Battle of the Bulge in December 1944 tested the rifle under winter conditions. Temperatures dropped below freezing, snow covered the Ardennes forest, and soldiers fought in the coldest European winter in decades. The M1 functioned in extreme cold, though soldiers learned to use lighter lubricants that would not freeze. Excessive oil applied in moderate conditions could congeal in sub-zero temperatures, slowing the action or causing malfunctions. Veterans developed informal knowledge about maintaining weapons in winter, keeping rifles inside sleeping bags when possible to prevent ice from forming on metal surfaces, and test-firing weapons in the morning to ensure actions operated freely. The Pacific Island campaigns of 1944 and 1945 showcased the M1 Garand in some of the war's most intense combat. Peleliu, Iwo Jima, and Okinawa saw American Marines and soldiers fighting Japanese defenders in terrain ranging from coral limestone caves to volcanic sand beaches. The rifle's reliability in these conditions, with exposure to salt, sand, rain, and the volcanic dust of islands like Iwo Jima, demonstrated the robustness of its design. Soldiers fighting in the Pacific developed deep trust in the weapon, knowing that their lives depended on its continued function during sustained combat. Combat loading techniques evolved through battlefield experience. Soldiers learned to carry multiple 8-round clips in canvas bandoliers, in pockets, and in specialized pouches. Loading a fresh clip under stress required practice. The procedure involved pulling the bolt back and locking it to the rear, inserting the clip from above and pressing down firmly until it clicked into place, then releasing the bolt to chamber the first round. Under fire, with adrenaline surging and hands potentially shaking, soldiers sometimes fumbled loads or caught thumbs. Veterans became proficient, capable of reloading in seconds without looking, by feel alone. The tactical impact of the M1 Garand extended beyond individual firefights. Squad and platoon tactics evolved to leverage the weapon's capabilities. Fire and maneuver, the fundamental infantry tactic of using one element to suppress the enemy, while another element moves, became more effective when the suppressing element could maintain sustained fire. Previously, this role fell primarily to machine gun crews. With M1 Garands, every rifleman contributed to suppressive fire, allowing more flexible tactical employment of forces. German soldiers captured during the war provided accounts of facing American infantry armed with M1 rifles. Reports filtered back through Wehrmacht intelligence channels, describing the psychological impact of facing semi-automatic rifle fire. German infantry, trained to fire their bolt-action rifles rapidly through intensive practice, found that even their best efforts could not match the volume of fire from American riflemen of average skill. Some German accounts refer to the M1 as a semi-automatic plague, a weapon that seemed to provide every American soldier with the firepower of a light machine gun. The rifle's accuracy contributed significantly to its effectiveness. At ranges up to 400 yards, a competent marksman with an M1 Garand could hit man-sized targets consistently. The weapon's sights, a rear aperture and front post, provided a clear sight picture. The trigger, while not as light as target rifles, broke cleanly after approximately 5 to 6 pounds of pressure. The rifle's accuracy potential exceeded what most combat situations required, capable of grouping shots within a few inches at 100 yards when fired from a stable position. By war's end in 1945, the M1 Garand had established itself as the defining infantry weapon of American ground forces. From the first shots fired in anger on Guadalcanal to the final battles in Germany and Okinawa, the rifle had performed in every climate and terrain where American soldiers fought. It had proven reliable, accurate, and durable, fulfilling and exceeding the expectations that had led to its adoption nearly a decade earlier. The tactical advantages it provided had been purchased with American industrial capacity and economic resources, but those advantages had been confirmed in blood and combat across 3 years of global warfare. Chapter 4. The Enemy's View. The German Wehrmacht, often portrayed as the epitome of military efficiency and technological sophistication, found itself confronting an uncomfortable reality by mid-1943. American infantry possessed a significant material advantage in small arms firepower that German forces could not easily counter. Intelligence reports flowing back to German military headquarters from every front where Wehrmacht units engaged American forces contained consistent observations about the M1 Garand's impact on combat effectiveness. German military intelligence maintained detailed files on Allied weapons and equipment. Reports on the M1 Garand described it with professional assessment mixed with grudging respect. German intelligence designated it as the Selbstladegewehr M1, literally self-loading rifle M1, and analyses noted its semi-automatic operation, 8-round capacity, and chambering for the powerful .30-06 cartridge. What concerned German military planners more than the rifle's technical specifications was its deployment at scale. Every American infantryman carried a semi-automatic rifle as standard issue, not as specialized equipment for select troops. Interrogations of German prisoners captured by American forces revealed perspectives from soldiers who had experienced M1 fire firsthand. Many German veterans, particularly those who had fought on the Eastern Front before being transferred west, noted that American rifle fire possessed a cadence and volume distinctly different from Soviet forces. While Soviet infantry had been equipped predominantly with bolt-action Maschinen-Nagant rifles, supplemented by large numbers of PPSH submachine guns for close combat, American infantry delivered accurate semi-automatic rifle fire at medium ranges where submachine guns lost effectiveness. The term semi-automatic plague appeared in several German military documents and prisoner accounts from 1943 onward, though historians debate the exact origins and prevalence of this phrase. Whether it was an official designation or informal soldier slang, the sentiment it expressed was genuine. German infantry armed with Kar-98K bolt-action rifles found themselves at a systematic disadvantage in firefights where both sides engaged at ranges between 100 and 400 yards. At these distances, beyond effective submachine gun range but within the engagement envelope where riflemen fought, the American ability to fire rapidly without working a bolt provided a measurable advantage. German tactical doctrine emphasized marksmanship and fire discipline. German soldiers were trained to take aimed shots, making each round count. The Kar-98K was an excellent weapon for this approach, accurate and reliable, with a smooth bolt action that allowed trained soldiers to cycle rapidly. Yet even a highly trained German soldier firing his Kar-98K as quickly as possible could not match the rate of accurate fire that an American soldier of average skill could achieve with an M1 Garand. The mathematics of sustained fire favoured the semi-automatic weapon decisively. This disadvantage manifested in squad-level engagements throughout the European theatre. When an American squad of 12 men engaged a German squad of similar size, the Americans could deliver significantly higher volumes of accurate fire during the initial moments of contact. Those first seconds often determined the outcome of small unit engagements, as the side that could establish fire superiority typically forced the other to seek cover or withdraw. The M1 Garand gave American infantry a structural advantage in these critical opening moments. German forces attempted to compensate through other means. The MG-34 and later MG-42 machine guns provided German squads with substantial automatic fire capability. These weapons, particularly the MG-42 with its extremely high rate of fire, gave German infantry organic fire support that often exceeded what American squads could produce. German tactical doctrine built around the machine gun as the primary weapon, with riflemen supporting and protecting the machine gun crew. This approach partially offset the American advantage in individual rifle firepower, though it created different vulnerabilities. If the machine gun was disabled or its crew killed, the squad's firepower dropped dramatically. Japanese military forces had their own experience with the M1 Garand, beginning in the Pacific campaigns. Japanese infantry doctrine emphasized aggressive close combat, with bayonet charges and infiltration tactics designed to close with enemy forces where Japanese soldiers' discipline and willingness to accept casualties could prove decisive. The M1 Garand severely complicated these tactics. American soldiers who could fire 8 rounds rapidly without working a bolt possessed a distinct advantage when Japanese forces attempted to close to bayonet range. Japanese military intelligence produced technical studies of captured American weapons. M1 Garands retrieved from American casualties or captured during early Pacific victories received detailed examination by Japanese ordnance experts. These analyses documented the rifle's construction, operation and design features. Japanese engineers understood the weapon's technical sophistication and the manufacturing precision required to produce it reliably. Some Japanese military planners recognized that American industrial capacity allowed mass production of such weapons in quantities Japan could not hope to match. Japanese soldiers who faced American forces armed with M1 rifles provided accounts after the war describing the impact of rapid semi-automatic fire. The psychological effect of facing an enemy where every soldier could deliver sustained rapid fire influenced Japanese tactical approaches. Infiltration tactics that relied on surprise and shock action became more difficult against defenders who could respond with immediate high-volume fire. Night attacks, a Japanese specialty, remained dangerous for American forces but became costlier for Japanese attackers when defenders with M1 rifles could fire rapidly in any direction without the delay of working a bolt. The myth surrounding the M1 Garand's ejection ping deserves particular examination from the enemy perspective. According to legend, enemy soldiers listened for the distinctive sound of the empty clip ejecting, recognizing it as an opportunity to attack while the American riflemen reloaded. Stories circulated among American veterans about enemy troops attempting to exploit this momentary vulnerability. Post-war interviews with German and Japanese veterans present a more ambiguous picture. Some enemy soldiers did recall hearing the ping in combat situations, particularly during quiet moments or when close to American positions. However, the tactical value of this information appears to have been limited. In most combat scenarios, multiple rifles were firing, explosions and artillery created ambient noise, and the din of battle made identifying individual reload sounds difficult. A German or Japanese soldier who exposed himself to attack an American position based on hearing a single clip eject would still face fire from other American soldiers whose rifles remained loaded. Squad tactics involving staggered reloading meant that rarely did all riflemen in a position reload simultaneously. Moreover, experienced enemy soldiers understood that approaching a position based on hearing what might be a reload sound was extraordinarily risky. The delay between the clip ejection and a fresh clip being inserted and the rifle being ready to fire was typically only a few seconds for a trained soldier. Attempting to rush a position in that brief window offered little advantage and substantial risk. Most German and Japanese veterans interviewed after the war suggested that the ping was more of a distinctive auditory memory than a tactical factor that significantly influenced their combat actions. The psychological dimension of facing the M1 Garand extended beyond the mechanics of firepower. Enemy soldiers recognized that American infantry possessed material advantages not just in rifles, but in artillery support, air superiority, logistics, and overall resources. The M1 Garand became a symbol of American industrial and economic power, made tangible in infantry combat. Every German or Japanese soldier who faced American forces understood that their enemy could afford to equip every infantryman with a sophisticated semi-automatic rifle that their own nations could not produce in comparable quantities. This recognition carried implications for morale and confidence. German soldiers on the Western Front, particularly after 1943, understood that they fought an enemy with superior material resources. Japanese forces in the Pacific faced opponents whose industrial capacity ensured that ammunition, equipment and supplies flowed in quantities that Japan could not sustain. The M1 Garand, in enemy eyes, represented more than a weapon. It symbolized the broader disparity in industrial capacity between the United States and its opponents. German attempts to develop comparable semi-automatic rifles met with limited success. The Gewehr 43, a gas-operated semi-automatic rifle, entered production in 1943, but manufacturing challenges and material shortages prevented its deployment in numbers sufficient to replace the Kar-98K as the standard infantry weapon. German forces continued to rely primarily on bolt-action rifles throughout the war, supplemented by submachine guns and machine guns. The Wehrmacht never achieved the systematic equipping of infantry with semi-automatic rifles that American forces accomplished. Japanese ordnance development similarly failed to produce a semi-automatic rifle that could be manufactured in sufficient quantities for general issue. Japan's industrial limitations, compounded by strategic bombing and resource shortages, meant that Japanese infantry fought the war with bolt-action rifles, Arisaka rifles, supplemented by light machine guns and limited numbers of submachine guns. The gap between Japanese and American infantry firepower, already significant at the war's beginning, widened as the conflict progressed. From the enemy perspective, the M1 Garand represented a challenge that could not be overcome through better training or superior tactics alone. It was a material advantage built into the basic equipment that every American infantryman carried. German and Japanese forces adapted their tactics, emphasized their own strengths, and fought with courage and skill. Yet in the fundamental arithmetic of small unit firefights, the American soldier with his M1 Garand entered combat with an advantage that enemies armed with bolt-action rifles could not match. Chapter 5: Legacy of the Ping. The end of the Second World War in August 1945 did not mark the end of the M1 Garand service. The rifle that had proven itself across the battlefields of two hemispheres remained the standard American infantry weapon, and when war erupted on the Korean Peninsula in June 1950, American soldiers carried M1 Garands into a new conflict against a different enemy and terrain that tested the weapon once again. Korea presented environmental challenges distinct from those of the Second World War. The mountainous terrain, extreme seasonal temperature variations, and the nature of combat against Chinese and North Korean forces created conditions where the M1's characteristics proved both advantageous and, in some circumstances, limiting. The weapon's weight, manageable in the relatively brief campaigns of World War II island fighting, became more noticeable during extended mountain patrols in Korea's rugged landscape. Yet the rifle's power and accuracy remained valuable at the longer engagement ranges that Korea's open terrain sometimes demanded. Winter combat in Korea tested the M1 Garand under conditions more severe than even the Battle of the Bulge. Temperatures during the first winter of the war, particularly during the fighting, around the Chosin Reservoir in late 1950, dropped to 30 below zero Fahrenheit. Soldiers learned that lubricants had to be carefully selected. Too much oil, or the wrong type, would freeze and render the rifle inoperable. Many soldiers ran their rifles nearly dry, with only minimal lubrication on critical bearing surfaces, accepting slightly increased wear in exchange for reliable function in extreme cold. Chinese forces in Korea, equipped primarily with bolt-action rifles and submachine guns, faced the same firepower disparity that German and Japanese forces had confronted in the previous war. Chinese infantry tactics emphasized mass assault and infiltration, attempting to overwhelm defensive positions through numbers and aggressive close combat. American forces, manning defensive perimeters with M1 Garands, could deliver devastating volumes of accurate fire against attacking forces. The rifle's semi-automatic capability proved decisive in situations where enemy troops attempted to close with American positions. Yet by 1950, military technology had advanced. The Wehrmacht's development of the Sturmgewehr 44 late in World War II had introduced the assault rifle concept, a select-fire weapon chambered for an intermediate cartridge less powerful than full-power rifle rounds, but more effective than pistol cartridges, combining the range of a rifle with the close combat firepower of a submachine gun. This concept would dominate infantry weapons development in the decades to come, but in Korea the M1 Garand remained the American standard. Discussion within military circles about the M1's replacement had begun even before Korea. The rifle, while excellent, was not without limitations. The 8-round clip, while sufficient in most combat situations, was fixed in capacity and could not be topped off with individual rounds. Once a soldier began firing from a clip, he typically fired all 8 rounds before reloading. The weight, while contributing to stability and recoil management, made the rifle heavier than necessary for its capabilities. The wood stock, traditional and aesthetically pleasing, was susceptible to warping in extreme humidity or temperature changes. Development of the M14 rifle, intended as the M1 Garand's replacement, began in the 1950s. The M14 retained the .30-06 cartridge's ballistic performance in a slightly shortened case, designated 7.62 by 51 mm NATO, compatible with the new NATO standardization. The M14 featured a detachable 20-round box magazine, select fire capability allowing both semi-automatic and automatic fire, and various modernizations in materials and construction. In 1957, the M14 was officially adopted, beginning the M1 Garand's transition to secondary roles, yet the transition took years. M1 Garands remained in service with reserve units, National Guard formations, and in ceremonial roles. Some saw combat in the early years of American involvement in Vietnam, though the M14 and later the M16 would define American infantry weapons in that conflict. The M1's service life in frontline American military use spanned from 1936 to the early 1960s, with limited use continuing into the mid-1960s in specialized roles. Beyond military service, the M1 Garand found a robust afterlife in several domains. The Civilian Marksmanship Program, a federally chartered organization promoting firearm safety and marksmanship, received large numbers of surplus M1 rifles for sale to qualified American citizens. These rifles found homes with collectors, target shooters, and individuals interested in military history. The M1 became one of the most sought-after military surplus rifles among American firearms enthusiasts. Competitive shooting embraced the M1 Garand enthusiastically. The rifle's accuracy made it suitable for high-power rifle competitions, where shooters engaged targets at ranges from 200 to 600 yards. Competitions specifically for M1 Garands developed, preserving the skills and knowledge associated with the weapon. Gunsmiths developed expertise in maintaining, repairing, and accurizing surplus M1 rifles, ensuring that examples built during World War II could continue functioning decades later. Collectors pursued M1 Garands with particular enthusiasm. The variations between manufacturers, different serial number ranges, wartime modifications, and the history of specific rifles created a rich field for collecting. A Springfield Armory M1 from 1943, a Winchester from 1944, an International Harvester from 1953, each represented different aspects of the rifle's production history. Rifles with documented battlefield provenance, captured enemy weapons, or examples used in specific campaigns commanded premium prices among serious collectors. The M1's cultural impact extended into popular memory and media. The rifle appeared in countless films depicting World War II and Korea, becoming a visual symbol of American infantry in those conflicts. Veterans' memories of the weapon contributed to its legendary status. The distinctive ping of the ejecting clip became an auditory signature instantly recognizable to anyone familiar with World War II history. The rifle embodied American military success during what many Americans viewed as unambiguous conflicts, fought for clear moral purposes. General George S. Patton's quote describing the M1 Garand as the greatest battle implement ever devised achieved lasting fame, frequently cited in discussions of military firearms. Whether Patton actually spoke those exact words remains debated among historians, as the primary source documentation is ambiguous, but the sentiment captured a widely held view of the rifle's significance. Patton, known for his aggressive leadership and emphasis on offensive action, recognized that the M1 Garand gave American infantry a decisive capability that enhanced their combat effectiveness. The rifle's design influenced subsequent military weapons development. The M14, while featuring different construction and capabilities, descended directly from the M1 Garand's operating system. The gas-operated mechanism, with minor modifications, continued in the M14. The emphasis on accuracy and reliability that characterized the M1 carried forward into its successor. Later, American military rifles, though representing different design philosophies, inherited lessons learned from decades of M1 Garand service. Today, more than 8 decades after its adoption, the M1 Garand remains in production in limited quantities. Springfield Armory, now a private company unrelated to the historical Federal Armory, produces new M1 rifles for the civilian market. Companies specializing in military firearms reproductions manufacture components, allowing old rifles to be maintained and restored. The rifle that armed American infantry in the mid-20th century continues to fire on ranges across America, maintained by enthusiasts and historians dedicated to preserving its legacy. The M1 Garand story represents more than the history of a single weapon. It embodies the intersection of design innovation, industrial capacity, tactical doctrine, and combat effectiveness. John C. Garand's engineering created a mechanism that balanced complexity with reliability, precision with durability. American industry transformed that design into millions of rifles, each machined to tolerances that ensured function in the worst imaginable conditions. American military doctrine made the strategic decision to equip every infantryman with a semi-automatic rifle, accepting the additional cost in resources and logistics to provide a material advantage at the point of contact, and American soldiers proved the weapon in combat across every environment where modern warfare occurred. The rifle's legacy encompasses the tactical victories won by soldiers who carried it, the industrial achievement of producing it in sufficient quantities to arm millions, and the symbolic resonance it achieved as an emblem of American military power in the 20th century. From the volcanic sands of Iwo Jima to the frozen ridges of Korea, from the hedgerows of Normandy to the jungles of Guadalcanal, the M1 Garand performed with a reliability and effectiveness that validated every decision that led to its creation and adoption. When the last empty clip flew skyward, the sound that followed was more than steel on steel. It was the echo of a nation that armed its soldiers not just to fight, but to endure. It was the product of factories and workers, of engineers and machinists, of doctrine and training, all combined to create a weapon that gave American infantry an advantage that enemies could not match and allies could not equal. The M1 Garand changed the face of war not through revolutionary tactics or strategic brilliance, but through the simple, profound reality that the soldier who can fire faster without sacrificing accuracy possesses a decisive advantage in infantry combat. That advantage, repeated in thousands of firefights across years of global conflict, helped determine the outcome of the greatest war in human history. The sound of thunder that echoed from that rifle carried with it the weight of a nation's industrial might and the skill of soldiers who trusted their lives to a weapon that did not fail them. In that trust, in that reliability, the M1 Garand earned its place in history as the rifle that changed modern warfare.